That'd just be the weird.
I think I'm gonna go with weird.
Hi, Mrs. Cristiano. This is our video blog for week 2.
Hi.
Hi.
All right, I don't think we have to introduce ourselves.
No, I don't think so either.
Yeah.
All right, I'm gonna start with what we thought was kind of weird about this one. We had a hard time agreeing because we got max height of 301.56, and we're talking about that with a 300-foot building. A person standing on top of it couldn't throw a ball only 1 foot above that 300-foot building. So we're having a hard time wrapping our minds around that fact.
And then I guess a pit would be the fact that we were overthinking this problem in terms of physics and trying to do way too much for something that's a lot simpler.
Yeah, and our peak was, we're all visual learners here, so it was very important that we drew something that represented what you gave us and also incorporated the different ways we learn.
All right, so since they just took all 3 of the discussions, I guess I'll just talk about my background in calculus, because I never sent you that student background. So, as I know that in calculus, you have your function for position, and then the derivative of that is your function for velocity. And knowing that, the derivative of one function is just its slope. So when we were trying to find, I'll just say that this is my peak. When we were trying to find the velocity of 0, it's basically when the slope equals 0. So that would be the peak right here. So again, we had a hard time because we got what was it? It was 5/16, right? It was 5/16.
Yes.
Yeah.
Yeah, so we got 5/16, which is 0.3125, and we felt like for the first and the second question was basically the exact same answer. One,
Like
because
the same question?
yeah, so it asked when the velocity was 0, and that would also be when it's at, or when the velocity is 0 is when it would be at its highest point. We think. We don't really know. So that was kind of weird, but also fun to talk about because, I mean, we tried to demonstrate throwing it a foot, but it doesn't, if you're trying to throw it up, it's not kind of...
It takes a lot of effort to only throw something up 1 foot, even if you'd have to be lying flat on your back on the top of the building.
All right, and then walking through it still, how long was the penny in the air? So we figured we would just have to find where y equals 0, and we found 4.65, but that is based on the building being the y-axis. So, you know, I think
You'd have to be standing right at the edge of
Yeah.
the building,
Mm-hmm.
like almost falling off of the building.
Yeah, and we know we found the vertex.
Yeah, the vertex would be the 0.3125, 301.56,
Yeah. Okay, so
where it's 0.
So we know that the vertex is away from the y-axis. So this could make sense. How fast is it going when it hits the ground? So to find that out, we just plugged in the 4.65, which was our 0 for y. And we ended up with 138.8, which would be right here.
No, you gotta use this blue one. Blue one's a good one.
All right, how long is this video? She said only a couple minutes.
It's almost 4.
Yeah.
I think.
All right. And that's what we're concluding.